So let's pause right before I teach you the last important thing. And honestly, all it is taking those equations like that have matrices in them and solving them. That's the last little step. So far, we've already set up, if we had an equation like this, don't write this down, just listen. 2x plus 2y is equal to 7. And 3x plus 4y is equal to 16. We've set up matrices for this. Do you remember setting up a matrix for this? Now, you don't have to copy my question. Just make the matrix for it. Remember, you just take the numbers out of it and stick them in the matrix. It's not that hard. So for instance, across the top, it's the 2 and the 2 and the 7. That's it, 2, 2, 7. Sid, what's the bottom row? 3, 4, 16. And then you can do something to that to turn it into an actual answer. Like you can get the answer, which is what are x and y? All right. Now there's another kind of matrix equation. They aren't all just like one big matrix. There's another kind that you're going to see more of today. And this is a little bit what we did yesterday. 2107 xy 3048. Don't write this down, just listen for a second. If I wanted to solve this, I'd want to get rid of this matrix right here, which I'm going to call the A matrix, and that's the B matrix. Now, what we taught you to do yesterday was to find the inverse by hand so that you could get rid of this. Okay? I want to remind you that if you do find the inverse, it's going to be A to the negative 1. The calculator can do it for you. You can also do it by hand. And then you're going to do A to the negative 1 here. And that's what it does is this will cancel this. And it'll turn it into the identity matrix. You don't even have to show that. You can just bring this side down as xy. And you just need to do the inverse of A and times it by B. And the answer will go here. All right. So to do that, wouldn't you need to put the A matrix and the B matrix into the calculator? All right, so let's start like we have every single day, which is to clear your calculator. Because you have matrices in there right now. And it'll be a pain. You just might as well wipe them. And it also fixes other stuff. Hit the second key. And then plus. And then 7. And then 1. And then 2. To get your calculator wiped to factory new. And it takes out all your old equations. All right, now let's actually put in these two as our matrices. Matrix A is, I'm going to erase these white lines. It's 2107. I'll rewrite the numbers in there, but 2107. And then matrix B is over here, 3048. And you got to find the inverse of A. Would you please start with that and just figure out what inverse A is? It's that part right there. You're doing A to the power of negative 1 and then hit enter. It'll probably be weird decimals. So then change them to fractions with math enter. All right. So you're taking this matrix right here, the A matrix, and doing the inverse of A. I will walk around and make sure you got this. See, Sophia, I checked yours. Can you read me what inverse of A comes out to be? 1/2. And let's go to the right of that. And as a fraction?
Yeah, -1/14.
Negative 1/14. Good. Keep going.
0.
And?
1/7.
Awesome. Now, what that will do, inverse of A, what that will do is when you times it by B, it'll give you the answer. So everybody take this now and times it by B. It'll look like this on your screen. And hit enter. And I know you've been done with this for a while, Gavin. Can you tell me the answer? As fractions.
3 over 2, negative 3 over 14, 2.
3 over 2, negative 3 over 14.
Yeah. Then 2, then 6 over 7.
And then 6 over 7. Can anybody verify this? Don't just say yes. I really need to know. Did anybody else get that? A lot of people are getting something else. All right. In the back, Wilkie, can you tell me what you got?
I got 17 over 14.
All right. And I was expecting an answer like that. 17 and 14, like that?
Oh, no, like
17 over 14?
yeah.
Okay. And then what?
And then negative 4 over 7
Is it the end? Or is there more numbers?
to the right.
Okay. And the one to the right is what?
Negative 4 over 7.
Okay, I wasn't expecting this, but did anybody else get that answer? Okay, a lot of people got that answer. Let's keep going with that answer then. Keep going.
4 over 7.
4 over 7
And then 8 over 7.
and 8 over 7. Okay. Now, what this means is that this is the matrix that would have had to have been right here in order to have this times that equal this. Okay, cool. Now, we need to move on. And I know that these are hard, but I just have one last thing to teach you, and then we get to practice for today, and then practice all day on Monday, and then you'll be ready for the test. And I know some people are stressed out. I get it. This is hard stuff. All right, so I'd like you to just find this one. It's blue. It's the second page of the notes.
Mr. Chairman, when's the cumulative?
The cumulative comes after this unit, so next week. It's probably Friday of next week. All right, so right now, if you have to get this solved, do you get this is going to be the A matrix and this is going to be the B matrix? All right, this one's going to come out to a more normal answer that's a 2 by 1 matrix. So you'll see this one will look more like what I kind of predicted it would look like. But anyway, for right now, would you just get your A matrix in as this and your B matrix in as that? Now remember what we're trying to do. We're trying to multiply by the inverse of A, and we're going to do it on both sides. But we don't really need to do it because we know that's going to just cancel out. That's what the point is. Inverse A times A cancels it out. And it turns into 1. So we don't need to do this side. We just need to do inverse of A times B. That's it. So go ahead and go right to the punchline. Once you got A in there, once you got B in there, type inverse A times B. And when you do, would you please compare it to the kid sitting next to you? I'm going to pause while I give this a shot. Well, a lot of people just don't know what it means at all. But it means that the formula won't work that has 1 over the determinant times flip-flop op-op. Do you remember that thing? That was for finding the inverse. And if the determinant is 0, you can't find the inverse. How many of you knew that? I'm curious. Oh, that's most of you. Good. You can't find the inverse. All right, well, was this one's determinant 0? No. So we can find the inverse. I'll leave that little flip-flop op-op up there for you to kind of remind you, since our determinant is 16, we're actually done with the hardest part. Linsmeyer, it's 1 over 16, and then what? You know what the flip-flop means?
Just like flip them around?
Yeah, so the 4 and the 4, it's weird because then there's still a 4 and 4, right?
Yeah.
And how about negative 0?
Just stays 0.
Yeah.
And it's negative 1.
Yes. And now you could do this in your head all day long, easy peasy. You just take everything and divide it by 16. Your final answer would be 4 over 16, which does reduce, but I'm not do that later. 4 over 16, 0 over 16, and some people are going to freak out on that, and they're wrong. Don't freak out on that. And then negative 1 over 16, and then 4 over 16 again. Would you please simplify this and compare with the kid next to you? Sophia, what'd you get?
1, 4, 0, negative 1, 16, and 1.
That's it. There you go. So, is it incredibly hard to find an inverse? No, it's not incredibly hard. You just got to know how to find the determinant. And you do have to know that little formula. 1 over the determinant, and this is these two flip-flop, which in the case of a 4 and a 4 doesn't really matter. And then op means you'd make it the opposite of this one and the opposite of that one. So these two flip-flop, these two become the opposite. Okay, all right. So let's get to the third slide and see if without speaking, if I can just encourage you to answer this question. All right, so I knew this was the A matrix. I knew this was the B matrix. I knew that to solve it, it even gives a big hint. Write down the inverse of this. Okay, so I used the calculator and it just said, hey, do the inverse for me. And it said the inverse was negative 2, 1, 1.5, and negative 0.5. Now, do those have to be fractions? No, they're small little decimals. They're fine. It's only when the decimals are super long that we would say you got to change that to a, what do you call that? You got to change that to a fraction. All right, Sophia.
I was wondering how I got negative 2.
Okay, it's possible that my A matrix is messed up. I will double check it. I'm going to go back to matrices. My A matrix is 1, 2, 3, and 4. I'm pretty sure I did it right. I don't know. Can anybody else verify? Did you get the same inverse of A? Okay. So maybe you just typed in your matrix wrong for A. Seriously. Just go look at your A matrix. See if you typed it in wrong. Okay. And now, to get the final answer, I really am doing this. I'm doing it on both sides. But don't forget that the inverse A has to be on the left when you times it by B. And when I did that, I did inverse of A times B, which is really just this. And I got a final answer of negative 3, negative 4, 4, 5. Yes?
So I solved it by hand, started with matrix A, and I did like the cross multiply situation and subtraction times the determinant, and I got 1/2 as my determinant, and then I multiplied all.
Okay, hold on. So you're just saying that you did this by hand, and I think you're about to tell me it didn't come out to that?
It came out as every single number correct except for the negatives. They were like flipped, like everything. I got 2, negative 1, negative 1.5, and so.
Okay. I just want to make sure first before I answer your question. Can anybody verify that who had the same inverse as me? Okay. So then you just did your inverse wrong. And I'll help you one-on-one to see what you did wrong on your inverse. You tried to do it in your head. I appreciate that. That's cool, but you did something wrong in that process. I think I heard what you guys were saying. You got to start with this times this minus this times this. Is that what the problem was? Did you do it backwards? Yeah, because it'll make a difference. In fact, that would account for the negative being off. That would totally make sense. Because like 3 minus 5 and 5 minus 3, they're very similar. One's just the opposite of the other. So, okay. All right. So now we got to be able to get from this to, instead of just putting it all into one matrix, what if we put it into two matrices? Is that part making sense so far? Instead of just pulling out all the numbers, the 2 and the 1 here and the 5 and the 5 and the 3 and the 13, but instead we put it into two matrices like that. Then you could split this one into just the numbers and just the variables. See, it's got a 2 and a 1 and a 5 and a 3. 2, 1, 5, 3. And then they pulled the variables out and put them in a 2 by 1 matrix right here. See, the point is, if I had just given you this problem, you now know how to solve that. This is A, this is B, and you'd do the inverse of A. Sorry, not negative A to the negative 1 on both sides, and you'd get the answer, right? So the question is, can you start with the two equations, break them up into matrices, and make the problem yourself? And of course, the next level of this is, can I just tell you a story like on last unit? And that allows you to write, thankfully, it's way less equations than last unit. Write two equations from your story, and then break your two equations up, and then break them up into just the normal setup with the x's and y's here, and then solve them. See, I just taught you this last part. You should be able to take this and solve it with inverse A times B. But can you start with these equations first? All right, so if we just had to solve this, I'm confident you can do it. I don't even want to do this slide because I'm confident you'd know this is the A matrix, this is the B matrix, and you would go inverse of A times B. And then that'll cancel this. And you just have inverse of A times B and you're done. I'm not worried about that. What I'm worried about is if I just give you two equations, can you make those into matrices? So let's just do that. We aren't even going to solve it. We're just going to see, can you make this into matrices? I'll give you a hint. The X and the Y always go right there. Claire, if X and Y go here, can you tell me what goes in front of that? 1, negative 3, 2, and 5. Perfect. That came from here. 1 and negative 3 and 2 and 5. And then the end ones are super easy. 4 and negative 3. Do you get that? Really wasn't that hard? And now this is the A matrix. This is the B matrix. You're probably getting sick of hearing this, but I just want to make sure you get it. Now you just do inverse of A in front of the B, and that can be done in the calculator, and you'll be done. Yes?
On the exam, I'm wondering, do you want to see our work?
Oh, absolutely. Just hear yourself. Do I want to see your work? Of course I want to see your work.
Although it's in the calculator, you don't.
You'll have to show me these equations. In fact, the problem will even probably say, write your equations first and then solve it. But yes, absolutely need to see your work. Now I get, from here, I know what you're going to do. So I know that you're going to do inverse A times B. But you still got to show at least that much. And then you can go right to the answer, which would be XY is, and I'm not sure what this one is. Let's say it's 2, 5. It'll come out to just two numbers like that.
Do you just leave it by hand though, by the inverse? Or-
Everything I wrote on the board, you have to show. Now, do you have to do the inverse by hand? No. But there might be a problem on a different place on the test that says 2174A. Find the determinant. And if you know how to do the determinant, it's not that hard. It's just this times this minus this times that. Okay? But if you had a calculator issue, like all I could do is the calculator, then you wouldn't be able to do it. And I also could ask you what's the inverse of this. Again, no calculator because it's got an A in it. And that would be a pretty complicated one. But another way we do it sometimes is we give you so bottom line, you have to know how to do the inverse and the determinant by hand. But it won't necessarily be in the middle of this question. Might be a simpler, separate question. Just show me all your work for solving this, or show me all your work for getting the inverse. All right, so let's move on to this page. Everybody find the green page. Without me helping at all, can you set up? Just set it up. Don't even solve it. Just set it up. Yes.
For questions like this one that we did earlier, like the 4/16 R test, do you want us to simplify it?
I do want you to simplify it, but I have a simple answer for that. For every test we've ever done, you've always had to simplify. And you will have to simplify. Yes. Now the good news is you're probably using a calc, and the calc simplifies automatically. So the part where you got these fractions, those will be calculator fractions. You with me? Yeah. All right, good. Write the equations for this. Not asking you to do it out loud, just on your iPad. Morgan, can you tell me the first matrix? It's a little square matrix.
I have 2
2,
and -4 on top,
-4,
-6 and 12.
-6, 12. Good. Now, if we wanted to make it tricky because you're in an honors class, what if there hadn't been an X here? What would you have put in here if there was no X's? If that didn't exist, then you would have put a 0 right here. You know what I'm saying? Because it has 0 X's in that equation. Okay, now, not saying we're for sure going to do that, but that would be fair game. But this equation, it has nice, simple, a number in front of everything. And I'm just trying to say there can be a 0 in front of an X. If there isn't an X, that's what's happening. All right, and then the X and the Y will always be there. Say to yes. I know you know this, so it's too insultingly easy to ask you, but I'd like you to tell me the next step. If we were going to solve it, act like I'm your calculator. Tell me what to do.
The inverse of A.
First of all, that's A. I'd have to put that in as A, and then what's the other one?
-3 to A is B.
Yep. And then what am I supposed to do?
A to the power of -1.
A to the -1, and that tells me the inverse of A, and then what do I do with that?
Times it by B.
That's it. I think you guys can do that now, so let's not waste the time. And then when the answer comes out 9 -1, what does that mean? Miss Kimber, what's that mean?
That X is 9.
Yep.
Y is -1.
Yep. I'm not saying that's the actual answer to this. I'm just saying if it came out this way, that's what it means. It's telling you what X and Y are. All right, so now it's a triple. And this one doesn't have an X. And yet I think you're going to know how to set it up. But we will find out. Just set it up. Don't need you to solve it. Just the setup. Logan, if I start 114, is that how you started? Good. What was next? 025. Nice. You knew to put a 0x right there, and that's a 0 here. Cool. And then what? Perfect. And then What goes here?
X, Y, Z.
Oh, you just knew it. Perfect. I never taught you that, but you figured it out through like logic. Brooklyn, it's 2, 4, 7. That'd be insultingly easy. 2, 4, -7 actually. But if act like I'm a smart AI and tell me what to do.
I would start by labeling the first matrices as A.
Okay.
And then the last one as B.
And then,
And then I would get the inverse of A.
nice.
Multiply it by B.
You got it. And if you want to still know, like, why would we do that? It's because inverse of A would cancel off regular A, and that would get this to go away. Technically, there'd be a big identity matrix, which is like a 1 running down the middle of it. But that's like 1. And then the answer really comes from over here. Inverse A times B. And then XYZ is that. Yes?
Do we have to write do we have to write the identity matrix
No.
in the test?
You don't have to write the identity matrix. It's kind of like I don't make you write 1x on a test. You can just say X. So you don't have to write the identity matrix part. I'm not saying you don't have to know what it is, because they might ask you on a question, what's the identity matrix? Let's just do that. Give me a 3x3 identity matrix. Act like it's a test. What's a 3x3 identity matrix? If you don't know, you'll know in 2 seconds here. A 3x3 identity matrix. You would have thought it was 1, 1, 1, 1, 1, 1, 1, but it's not. It's 1, 0, 0, 0, 1, 0, and 0, 0, 1. Raise your hand if you had that one right. Cool. That's what I'd expect you to know about the identity matrix. Or maybe that when two things that are inverses get multiplied, you get this. That's the point of the identity matrix, is that if I take inverse of A and I times it by A, it'll cancel out and turn into that. That's the answer. That's like 1. That's what happens when you multiply 2 inverses. Questions? All right, now go to this one. They just jumbled it up. So the X's and the Y's and the Z's aren't all lined up nice. So unjumble it. Organize it. All right, so this is me taking that top one and organizing it so it's X and then Y and then Z, but my problem is I put Z first. I really need to have X first. So I'm just gonna not show how I did this. I'm just gonna reverse these two. The 4X is gonna be first. And the Y is gonna be next, minus 4Y. And the Z is going to be last. Now, somebody, I guarantee you, is going to say, Mr. Server, I got exactly the opposite of everything you have. I got negative 4X, positive 4Y, negative Z, and negative 13. That works. Did you know that you could always multiply by negative 1 through the whole equation? So if you ended up solving this one another way, and getting the opposite of everything I have, it's fine. negative 4x, positive 4y, negative z, and negative 13 would work fine. It's like multiplying it all by negative 1. So maybe you didn't do that, but just if that happens, it'll be fine. All right, now I need this one, which, thank heavens, is in order with x, y, and then z. So I have x plus 2y minus 2z equals 10. And then the last one, which I'm getting the idea, I want everything on the left, so I'm going to have my x first. And then I'm going to have no y's, because it doesn't have any y's in it, this one here. Minus 2z equals 10. And I got my 3 equations. Do you think I'm done? No, of course not. Then I got to make my matrices. And if I got 3 equations, I got 3 variables, x, y, z, just like that. And the last one's, if you get stuck, just always, like do something that's, like I know these 3 numbers are going to be in the last 3 matrices. So those 3 numbers are in the last matrix. All right, and I know these are x, y, and z. So then I guess the last thing I got to do is this, 4, negative 4, and that's 1. And then 1, 2, negative 2, and then 1, 0, negative 2. Now I could have very easily made a dumb mistake in there, and so could you. But who has the exact same thing that I do? A bunch of people do. All right, if you have a mistake in there, or you think I made a mistake, tell me where it is. I'll help. I'll double check it. All right, then I'm pretty sure this is right, and then I'm pretty sure you know how to solve it. That's A, that's B, and the big whammy at the end is you just do inverse A on both sides. Always has to be on the left. And this one isn't super special, it just cancels off. That's the actual answer, whatever inverse A times B is. And it'll come out to 3 numbers in a row like this. Like 2, 4, 7. And I'm not saying that's the answer, but it would be like that. All right, cool. So then, could we be as mean as giving you a problem? Now, if we do this on the test, we understand that we can't make the question one question, because if you make one mistake at the beginning of your equations, now everything's going to be wrong. So do you remember how in the last test we kind of broke it up in parts? We'd have to do that. Because if we make it just one question and a kid makes one dumb mistake in it, with our system where it doesn't help you much with partial credit, then you just bomb the test. Right? So, but theoretically, you should know all the parts to this. So let's just talk about the equations, because that's the one thing we haven't done lately. Now, let's make the first thing they mention chocolate chip versus gingerbread cookies. So let's make X chocolate chip and makes Y ginger. That's the first thing you'd have to do is figure out what X and Y are. And to be honest, on a test, we usually tell you in some way what X and Y are, because if the kid has it all backwards, it's a nightmare to grade. So we'll probably all agree on what X and Y are. But mathematically, you could actually choose either one. We're probably going to force you to pick X is this and Y is that. All right. So then, can you just tell me one of the 2 equations? 8 chocolate chip and 12 gingerbread is 364. Eight X plus 12Y equals 364. Make sense? All right. Sid, Carlos sold 1 package of chocolate chip, 4 packages of gingerbread, total of 93. What's the equation for that?
X plus 4y.
You got it. And then, just set up the equation. I trust you know how to solve it. Just set up the equation from here. I mean, we got equations, but can you make them in a matrix equations? Ginsburg, what are the four numbers in that first matrix?
12, 1, 4.
And then it's X and Y, and then it's 364, 93. And now just tell me if you were going to type in just letters at the end, because you already entered your matrices, what letters would be the final little sequence? So in other words, this is A, this is B. How would you get your final answer? Claire, you got this? Yup. That's it. Cool. Look, we did it from beginning to end, except we just didn't actually type them in at the very end, just to save time. And even with all that saving time, we went through most of the album. Okay, cool. So let's actually do some homework together. It's the odds. And wait a minute. I think it's the odds. Can you look in the title? I'm pretty sure I put the title. Yes, it says odds. Good. Okay. It's the odds. So let's start with number 1. Because once you started with your homework, you're halfway done. Somebody's done, and you just have to read me the problem, and I promise I won't call on you for the rest of the hour. Would somebody read me the problem? Fine. I actually figured that might happen, so I brought it up. It's really hard to read, I get it. So if I was going to solve this, you might be like, that looks totally different than what we just did. It does. I get it. But it's easier, actually. It really is. All right. You see this matrix right here? Whenever you solve an equation, you're always doing PEMDAS backwards. You always start with add and subtract. To get A alone, is there anything I could add or subtract to both sides? Yeah, I could add this blue matrix right here. I could add that to both sides. And that would get rid of it. If I added this matrix to both sides. And now I still have this. Negative 2a equals. And then we have to add matrices? Yes, in your head too. I mean, technically you could use a calculator, but man, that'd be sad. You're just adding. 23 and negative 7. Okay, that's kind of a pain. Well, it's like 23 and negative 4. Sorry, it's like 20 and negative 4. So I'm pretty sure it's 16. Anybody else get 16 without me? Good. 14 minus 3, that's 11. I can do that one easy. Negative 3 and positive 7, that's 4. And negative 20 and 6, negative 14. Is it done? No, because A isn't alone yet. How do, oh, question?
It's a negative 8.
Uh-oh, uh-oh. Caught a mistake. Oh, I couldn't read because I put a slash through it. Thank you. That's a negative 8 right there. So this should be a negative 8 right here. Thank you. And then 14 and the negative 8 together don't make 11. Thank you for catching that. My line had gone through just at a very unfortunate angle through the 8, making it look like a 3. Okay, so then pretty sure, man, my subtraction is bad today. So 4, so that's going to be 10 minus 4 is 6. Is that what you got? Okay, awesome. All right, cool. And then, how do you get this 2 off of here? And hint, the answer is not divide, because you can't divide matrices by anything. How could you get the 2 off of there without dividing? Multiply by what? And What's better than 1/2 in this situation? Negative 1/2. You multiply both sides by negative 1/2. I'm going to move my equal sign over here more. A got to be alone, and I really never had to do complicated inverses and stuff. All right. Final answer is whatever negative 1/2 of 16 is, so we'll just start it for you. So it'll be negative 8 here, and then you finish it off. All right. Glad we started that one because I know since we just did like 5 in a row that were like number 3, you probably would have struggled with number 1, but it was really pretty easy. All right, number 3. Do I have, all of them have an X and a Y and a Z? Just checking quick. Yes, they do. Cool. So then it's -1, -5, 3, -5, -5, 5, 2, 5, -3. And this is always the variables. In this case, there's 3 of them, X, Y, then Z. 17, 5, -10. This is one of the classics. That's an A. That's a B. Do inverse A times B. You said no big deal. I hope you feel that way on these problems. We did a whole bunch of them in a row. But I also get these are tricky. So if the test is Tuesday, Monday is your last chance to come in and get extra help. So if you know yourself and you work on it this weekend and you are so lost, well, then you really should make a plan to come in Monday morning. You don't have to tell me or anything. You just show up. I'll be here Monday morning if you want extra help. And then Tuesday's the test. If it bombs because you're terrible at this, then Wednesday and Thursday are review days for the cumulative, and then Friday is the cumulative. It's all making sense? All right. After that, you might be like, well, isn't this the last cumulative? It is the last cumulative, actually. So what are we doing next week after that? Next week after next week, we have one last unit on stats. And weirdly, it won't have a test. But the questions will appear, some questions will appear on the final, but only on the final. That'll save us the pain of having that last test. So literally, your last normal test is going to be the cumulative at the end of next week. And then, well, if you want to say normal, like not a cumulative, well, then this coming test on matrices is your last normal test. Then we have the cumulative. Then we have a unit on stats that doesn't have a test. And then we have the final. Okay, so there's the big picture for the end of the year. All right, I'm hoping that if you get stuck that you're going to come up and ask me for help. That's all I got for you for today.